Welcome back, everyone, to this lecture on grid search. Often, more complex models that we'll later learn about in the course have multiple adjustable hyperparameters. A grid search is a way of training and validating a model on every possible combination of multiple hyperparameter options. Scikit-learn includes a grid search CV class call, which is capable of testing a dictionary of user-defined hyperparameter options through cross-validation. This allows for both cross-validation and the grid search to be performed in a generalized way for any model. Let's go ahead and explore this in the Jupyter Notebook. Alright, here I am at the Jupyter Notebook, and I already have some setup code that you can easily copy and paste from the grid search lecture notebook. It's all code that we've seen before in the multiple previous lectures. It is my imports, reading in the data set, and then grabbing X and Y, performing a train test split, and scaling the data. All of that remains the same. So this is pretty much a swap-in for either the cross-validate function or the cross-val_score function. Let's imagine we're using a model that actually has two or more hyperparameters to adjust. What we could do is test every single combination of those two hyperparameters that we define. So let's explore a model that we've actually already worked with that actually has these multiple hyperparameters. Recall that we can use an elastic net model, which is going to balance out how much we should use of ridge regression versus how much we should use of lasso regression. Essentially, how much to use of the squared penalty term versus the absolute value penalty term. So we're going to import elastic net, and then if you call help on elastic net, this should be a nice reminder that it essentially takes in the two parameters, which is this L1 ratio and this overall alpha, which is another way of defining the lambda 1 and lambda 2. So again, just an L1 ratio between them and then an alpha score is the same way that we could define that lambda 1 and lambda 2 from the elastic net formula that we saw earlier. Go ahead and review elastic net lectures if you don't remember what these actual parameters stand for. So let me go ahead and then comment this out. So now I know I have alpha values and L1 ratio values. And I essentially want to find out what's the optimal alpha value and what's the optimal L1 value. And what I don't want to do is have to run a for loop that constantly checks through every single combination. Luckily for us, there is the grid search CV class call, which does all of that work for us behind the scenes. The first step in creating this is going to be a base model. So I will say base elastic net model is equal to an instance of elastic net. What's really important to note here is I don't bother actually defining any hyperparameters right now. You just make it the absolute default, and then what you're going to do is create what is known as a parameter grid, which comes in the form of a Python dictionary. And what you do is you check out what parameters you want to play around with inside your model. So clearly we can adjust both alpha and the L1 ratio. So then what we're going to do is using these exact strings, so alpha and L1 underscore ratio, the exact way it's written out here, I create keys in my dictionary. So I say I have my alpha key, colon, and it's going to be a list of optional values. And then I have my L1 underscore ratio key, colon, and then a list of optional values. Something to note here is that, again, these keys should match exactly with the way the argument is spelled out inside this class call. Then what we're going to do is give it a list of alpha values we want to check out. So maybe I want to check out 0.1, 1, 5, 10, let's go 50, and 100. And obviously you can read the documentation in scikit-learn to get a better idea of what good ranges are for the various hyperparameters of your model. And keep in mind, sometimes models have actual string codes that are options. So for example, you could have a complex model later on where there are different solvers you could use, like an LBG solver or something like that, that are actually string codes. All that means is that instead of numbers, you'd provide multiple string codes in that list. The next one is L1 ratio, and let's choose some values here. We'll say 0.1, 0.5, 0.7, and let's go now a little higher, something like 0.95, 0.99, and then all the way to 1. And keep in mind again, if you check out the documentation for ElasticNet, it will begin giving you recommendations of ranges to explore. And you can also read ISLR for various ranges to kind of hone in on. And you could always come back and adjust these parameter grids if you want to check in between some ranges. So now that we've defined our parameter grid, it's time to actually perform the grid search. For this, we say from sklearn.model_selection import grid search CV. Go ahead and tab autocomplete that. And then we create our grid model. And this will feel very familiar from cross-val score and cross-validate. What we do here is we say an instance of grid search, CV, and then you'll notice it takes in a bunch of things. So it takes in an estimator, which is the model itself. It takes in the parameter grid, which is what we just find here as a dictionary. It takes the scoring. So recall, it's going to do a cross-validation, so you need a scoring metric. And then it'll also take things like CV, which is essentially how many folds you want to do for the cross-validation. And then it's also going to take then this verbose argument. And the verbose is just how much messaging or string output do you want to see during training. The higher the number, the more information it's going to play back to you. So keep in mind, what it's going to do is every single possible combination here. So for alpha of 0.1, it's going to try it with an L1 ratio of 0.1, 0.5, 0.7, 0.95, etc. As you can imagine, if you have lots of hyperparameters and lots of options for those, you're starting to test hundreds of combinations, so maybe you don't want to see the result of 100 combinations. Instead, you just say verbose is equal to 0 and don't see the output, just fit the model. So let's go ahead and explore this. For estimator, we'll go ahead and say this is the base elastic model. So base elastic net model. Then the param grid is just the parameter grid we defined earlier. And then scoring is going to be some string code that we're already used to from cross-validation. So I can say score this based off negative mean squared error. And then we'll say something like do 5 folds. Obviously, the higher folds, the more work is to be done. And for the case of this lecture, I'll say verbose is equal to 2. This is a number you can play around with. If you check out the grid search documentation and you scroll down here, it essentially explains for verbose, the higher the number, the more messages. Obviously, there's a limit on the integers. Usually it means 0 is like nothing is printed out, and 1 or 2 are the higher levels of information. You kind of do have to test it to see what information it brings back to you, but verbose is equal to 2. We'll go ahead and run that. So now we've defined this grid model, and what's really cool about scikit-learn is using this grid model is just like using any other model. We say grid model, and then we just call fit on X train and Y train. So again, in this context, this is essentially just another form of cross-validation where you conveniently happen to do the testing of all the potential parameters at the same step. Previously, you would have to do your cross-validation each time for your own parameter choices. Now, I can kind of kill 2 birds with 1 stone by checking out my various parameters and doing the cross-validation on them. So I fit this to X train and Y train. Go ahead and run this. And because I said verbose is equal to 2, you should see a bunch of information pop out as far as alpha L1 value, and then also kind of the time it took. If you go ahead and say verbose is equal to 0 and run these again, you'll notice it doesn't give you as much information. And if you do verbose is equal to 1, it'll give you kind of some information about what it's doing on the back end, but it won't tell you every single fit for 180 fits. Obviously, it's up to you how much information you actually want. Okay, so now what do we do? Well, we're only interested in the best estimator, so it actually scores them all based off negative mean squared error. And what I can do here is say grid model, go ahead and give me the best underscore estimator underscore. It runs it back, and it tells you it's going to be an elastic net with an alpha of 0.1 and an L1 ratio equal to 1. So this is the best estimator combination that it found, and if you're only interested in the best parameters, what you can also do is just say grid model best params underscore, and then it'll kind of just repeat it, but as a dictionary form. Now, sometimes you may be curious about the actual results for other combinations that were not the best scoring parameter combos. To do this, if we come back to grid search, you'll notice that one of the attributes is CV underscore results underscore. So if we check out that attribute, it's actually a dictionary. So we'll say grid model and then call CV underscore results underscore. And it's this giant dictionary, and we can pass this into a data frame to make it a little easier to read. And essentially, it's just a bunch of information of the mean fit time, standard deviation fit time, mean score time, etc., as well as the error information, so mean test score, standard deviation test score, rank test score, etc., for all the combinations possible. So you notice here the parameters. This are the results for an alpha of 0.1 and an L1 ratio of 0.1. here's alpha 0.1, L1 ratio of 0.5, etc. So it keeps going down and gives you all that information. You probably don't need every single column here. Obviously, you could just start selecting the columns you want from this data frame, but all this information is here for you in case you want it or need it. Now let's imagine we are fully satisfied with this performance. If we were not satisfied, we would just go back up here and start testing different ranges of alpha and L1 ratio. So maybe you want to test smaller alpha values somewhere between 0 and 0.2, and higher L1 ratios somewhere between 0.9 and all the way to 1. So obviously you could continue to hone in on this, but if you are satisfied with these particular results, what you could do is just use the best model from the grid search in order to predict and get some metrics. And the way we do this is almost as if it essentially was already a trained model. So we simply say 𝑦pred is equal to grid model, and you can call predict directly off of it. And when you're calling predict, it's just grabbing the best estimator and running it internally. So you pass in xtest, just as you would as if this was a normal model, and then say from scikit-learn.metrics import mean squared error, or really any error you want. So we'll say mean squared error. Whoops, there we go. And then let's calculate the mean squared error between ytest and my y predictions. And there we have our final reportable results. Okay, so really similar as far as the use cases to everything we've done before of cross-validation, but what's really nice about this is it does a lot of work through just one line call. This is running both a grid search and the cross-validation. Things to note here is that you're mainly paying for this simplicity with computational time. This is a very simple model and a simple data set, so it was not a big deal to run CV is equal to 5 with so many different combinations of hyperparameters. But as our models get more complex, this could take quite a long time to run, especially depending on your computer's hardware. Okay, that's it for the Grid Search CV class. Definitely check out the documentation, as there's lots of useful information for the different ways you can use this class call. Okay, thanks, and I'll see you at the next lecture.